My liquids do not like your liquids. And that's okay. That's how life organizes itself. Inside your body, in your cells, your molecules like to separate like oil and water. And that's perfectly fine. But sometimes those liquids harden, they stiffen, they get all sticky. And that's the basis of diseases like ALS, Parkinson's, cancer, and many others. So think about an egg. Inside the egg, you have the egg yolk and the egg white. They're both liquids floating around inside that eggshell, but they're clearly different liquids with clearly different functions. If you shook that egg up really hard and mixed them all together, you couldn't grow that baby chicken. Similarly, inside your body, you have things called condensates. These are little liquid droplets similar to the egg yolk, and they're very important. They're very busy. So let's say your cell's really stressed. It's too hot, too cold, too salty. Your condensates can basically sequester away your important molecules and keep them safe. Condensates also act as protein factories, making more and faster proteins. Or they can also act as storage lockers. I don't need this molecule today, but I need it tomorrow. I'm just going to store it away. But the problem happens when these condensates harden. So think back to the egg. If you heat it up and you have a boiled egg, you can't grow a chicken in a boiled egg. And you can never get a raw egg back. Something similar happens with condensates, and they turn sticky. So the stiffness starts with the proteins inside of the condensates. They get all sticky, and they pull in nearby healthy proteins and make them sticky too. Over time, those condensates harden, other condensates harden, until you have a bunch of hardened condensates. We call these zombie proteins because they're no longer functional, and they spread their stickiness to all their protein friends. And so what I study is what makes these condensates, what makes one of them turn into a zombie protein, and what makes them stay healthy. What attributes about their size and shape drives what happens. I look at the DNA. In the DNA, you have 3-letter codes called codons. And these codons say, hey, start making this protein. Now make this molecule, add a little bit of this molecule, and now stop, we're finished. As you can see, there's redundancy. There's 3 different ways you can tell the cell to stop making this protein. So I look at these subtle differences. Why would you choose one stop codon over another? And how does that impact whether the cell stays healthy and liquid or turns into a zombie protein? So liquid separation drives life and is very necessary. It's what helps cells organize, adapt, and survive. But when those boundaries blur, when those liquids harden, that's when zombie proteins arrive. So my liquids, they still don't like your liquids, but that's how we like it. Thank you.